All right. So let's talk a little bit about Section 6.2, real applications of normal uh, distributions. All right. So we're going to be dealing with finding areas under normal curves. That's kind of what's going to happen here. We have already done this in Section 6.1, finding these areas under normal curves. But what we're going to do here is we're now going to be finding areas under, but the curves that we found areas under in 6.1 were all the standard normal. So they just dealt with populations where we were dealing with z-scores, okay, where the mean is 0 and the standard deviation is 1. But if we're dealing with populations where the mean and the standard deviation are not 0 and 1, in other words, non-standard normal distributions, we can still find the area under the curve. We just will be converting from the non-standard to the standard. And the way we do that is by using the z-score. So the z-score formula. That converts all of our non-standard formulas to standard formulas. That allows us to standardize any normal distribution. All right? So the z-score formula changes us from non-standard to standard, right, and allows us to find areas under non-standard curves. All right, so if we look through this, here are the ways that we find these areas, and this is the same thing I've been saying all along. You want to draw a picture of your normal curve with the mean there, and then you want to represent your, draw in your boundaries, and then shade the region that you want to find the area of. All right, that you want to find the probability of. So that just makes things helps keep you from making mistakes. All right, so that's what we're going to do in all of these examples, just like we did before. We will draw that picture. And then what you're going to do, it says for each relevant value that is a boundary, convert it to its z-score. Convert it to its standard equivalent z-score. We've done that, and you'll see that in some examples here. And then we use the technology, either software, calculator, or table to find the area. So let's look at an example. What proportion of men are taller than 72 inches in height? So here's the problem. Heights are normally distributed. Okay? And so that means normally distributed, and the mean is 68.6. And the standard deviation, so we'll write it here, mean is 68.6, and the standard deviation is 2.8. Okay, find the percentage of men who are taller than a shower head of 72 inches. So this is 68, so 72 is going to be, somewhere up here. So that's where our boundary is. And then we're going to be shading. We want the area greater than that. So that's the area we want. Okay? And so to get that, you see the picture here. You're going to convert. Well, let's just do it here in total so that you can see it all total. So the first thing you do is, this is a z-score, or sorry, this is not a z-score. That is 72, like we said. But we need to convert it to its z-score, right? So its z-score is 72 minus 68.6 over 2.8. And that's going to give you the z-score of that boundary, right? So if we throw that into a calculator, we get 1.2. We want 2 decimals, so 1.21. All right? And so that's what we'll be looking up in our table. That's the z-score, 1.21. And so we're going to look that up in our table, right? So let's move up here. And when you look up in your table, you will find the area, the actual area to the table. Sorry, we'll move back here. The area in the table that they give us is the area to the left, right? Because our table only gives us left areas, right? So we'll just look up the area to the left, and that area to the left from the table is from 1.21, 0.88. So this area is 0.8869. So to find this area, you're going to do 1 minus 0.8869, right? So what's that, 0.1131, something like that. And that's the area, and that's the percentage of men who are taller than a shower head of 72. So did that match? We used the table, so our number's slightly different than their 0.1123 because we were rounding, and that's okay. They used some technology. And again, to find this area using technology, they would have done something like this. Normal CDF from 1.21 to say 1,000, comma 0, comma 1. They would have typed that in, and you should have gotten 0.1123. All right, let's look at another one. What proportion of men are taller than 72? I guess we're still working on that. I guess we've got it. So these are just the slides that show you the work. 0.1123, which we already went through, right? There it is using the table 0.8869, and there's our 0.1131. So how do we interpret that? That's important because it's one thing to be able to find the answers. It's another thing to know what they mean. The proportion of men taller than 72 is 0.1123 or 11.23%, right? So if you're building showers, in a hotel, and you decide, okay, I'm going to just make them 72 inches high, then that means you will accommodate, like 89% of the people, and 11% will be left out. All right. Okay, let's look at another way that this sometimes happens. We definitely want to use our graphs, okay, with the boundaries and the shading so that we know where things are. All right. We've talked about these things. Don't confuse z-scores with areas. All right. Z-scores are the distances. They're on the horizontal axis. The areas are the areas under the normal curve. The z-scores are on the outside of table 2. The areas are on the inside. And then make sure you're finding the correct area you want. And that's why we shade these things. Okay, some other little things to keep ourselves from making mistakes. A z-score is negative if it's left of the mean, and areas are always between 0 and 1. Okay, so let's look at a slightly different kind of problem here. So here we go. When designing equipment, one common criteria is to use a design that accommodates 95% of the population. All right, so we want to accommodate 95% of the population. We have seen that only 46% of women satisfy the height requirements to be an Air Force pilot. What would be the maximum? So that's less than 95, right? We want to build our airplane so that 95% of women can do that. What would be the maximum acceptable height of a woman if the requirements were changed to allow for the shortest 95%? All right, so we want to change things so that we can accommodate 95% of the women instead of 46% of the women. So in other words, we want to find the 95th percentile of the heights of women. Assume that women are normally distributed with a mean of 63.7 and a standard deviation of 2.9. All right. So here's how this works. First thing, we draw the picture, right? And you can see the picture there. Let me draw my version. It's going to look the same, but just so you can see, right? So we've got our normal curve, and we want some boundary here so that this area, this area is 0.95, right? We want this area to be 0.95. Right? And so that's the setup that we've got, and that's of course what they've drawn here. Now, so we're going to work kind of backwards. We're going to say, okay, we first need to find the z-score of this boundary. We know we've done this. We've got the area. Now we want to find the boundary. So we look in our table, our positive z-score table, for an area in the interior of the table of 0.95, or as close as we can get to it. So if I'm looking for 0.95, it's looking like the z-score associated with that is about 1.645. So that's the z-score. That must be the z-score of that boundary. Okay? But I need to know what that, I need to translate that z-score back to heights. Okay? And you can see how here how they're using technology to find that boundary. We're gonna we're gonna let you experience that, but I want to show you this by hand. So here's what I know. I don't know the x value, right? I know what the z-score is. It's 1.645. So I'm going to use my same z-score formula, right? My z-score formula looks like this: x minus mu over sigma. But here's what I know. I know 1.645, and I don't know x this time. I still know mu, and I still know standard deviation. Where's the standard deviation? 2.9. Right? So I'm still using the formula, but this time I know the z-score, and now I want to find the x value. So I do a little algebra, and right, so you're going to multiply both sides by 2.9. Okay, and let's see what that's going to give us. 2.9 times 1.645 is 4.7705 equals x minus 63.7. And then now we are going to add 63.7 to both sides. And we get 68.47 equals x. And so that is the we started with the standard score 1.645, and then we converted it to the non-standard score, which is more helpful because now this gives us an actual number of inches that we can use as our cutoff point. Okay. All right. So that's going to give us the answer. So let's work through here. So the result is 68.4705, and basically what that means is if we set the height requirement at that, then we will accommodate 95% of the women. All right, they will be eligible. Okay. Should there be a minimum requirement? I guess that's a question for another time, but this gives us the ability. So we've gone from two directions. Either you know the boundary and then you find the area, or you know the area and then you find the boundary. Either way, you use this same procedure.